Okay, here's the page 7 for unit circle. We're going to work on multiples of pi over 6 and pi over 4. Just a reminder, pi over 4 is 1/4 of a semicircle. So remember, semicircle is pi radians, so pi over 4 is 1/4 of the semicircle. So it's 45 degrees, right? Pi over 6, which is 1/6 of the semicircle, it's this thin slice here, it's 30 degrees, okay? So we're going to be working with these special angles. Use a unit circle diagram to find exact values for sine theta, cosine theta, and tangent theta for theta equals to pi over 4. So remember, pi over 4 is 45 degrees. So I'm going to draw a 45-degree right triangle here using the help of this unit circle template. I am going to write down the sine theta, cosine theta, and tangent values, okay, for this angle. Now remember, the length of the hypotenuse is always 1 in the unit circle. These two sides of 45 degrees are going to be medium length right triangle, square root of 2 over 2. They're both square root of 2 over 2. So, of course, the sine theta value, sine of pi over 4 would be square root of 2 over 2, and cosine pi over 4 would also be square root of 2 over 2. So they're both the same. Last of all, tangent of theta. Remember, tangent of theta is just the sine value divided by the cosine value, or we could say the opposite over the adjacent. So it's the same number over the same number, so that's equal to 1. And that's it for pi over 4. Let's do 7 pi over 4. So 7 pi over 4, that would be, let's see, 7 pi over 4, remember, is almost 8/4 pi, right? That would be 2 pi. That would be almost 360 degrees. It's just one 45-degree angle short of that. So that would be this angle here. Okay, so we would draw that right triangle. And of course, this right triangle also has sides that are square root of 2 over 2 long. But since the y-coordinate is negative, this would be a negative square root of 2 over 2. Okay? So the sine of 7/4 pi would be the y-coordinate of the blue triangle, so it'd be negative square root of 2 over 2. And the cosine of 7 pi over 4 would be the x-coordinate, which would be square root of 2 over 2, same as the red triangle. Okay, and finally, the tangent of 7 pi over 4, again, would be the sine value divided by the cosine value, or it would be the opposite over the adjacent, so that would be negative square root of 2 over 2 divided by square root of 2 over 2. Square root of 2 over 2's would cancel, and you would just end up with negative 1. Okay, all right, the last one, negative 3/4 pi. So negative 3/4 pi, instead of going positively around this unit circle, we're going to go this way. So 3/4 pi in the backwards direction would be this triangle right here, right? Okay, so again, the lengths of each of the sides are square root of 2 over 2. Now, since this triangle points to the left and down, both the x-coordinate and the y-coordinate would be negatives. Okay, so the sine of negative 3 pi over 4 would be the y-coordinate, which would be negative square root of 2 over 2. The cosine of negative 3 pi over 4 would also be negative square root of 2 over 2. And finally, the tangent of negative 3/4 pi, it would be the sine value divided by the cosine value. Since they're equal, they're both negative square root of 2 over 2. They would cancel each other out and give you 1. Okay, so there we go. We've analyzed those three angles that are multiples of 45 degrees. Okay, let's go down and look at some of the multiples of 30 degrees. Okay, so remember that pi over 6 is 30 degrees. Okay, and when we work with 30 degrees, we're going to be working with these angles here, specifically this one, and this one, and this one. Okay, because these other ones here, these ones are going to be multiples of 1/3 pi. Okay, all right. So for pi over 6, we are talking about 30 degrees. Starting in the positive direction here, that would be this triangle right here, right? So this is the triangle we're talking about. The short side would be length 1/2. The long side would be length square root of 3 over 2. So the sine of pi over 6 would be the y-coordinate, so it would be 1/2. The cosine of pi over 6 would be the x-coordinate, which would be square root of 3 over 2. And of course, the tangent value of pi over 6 would be the sine value divided by the cosine value. So we would do 1/2 divided by square root of 3 over 2. So basically the denominators cancel and we would end up with 1 over the square root of 3. Okay, so that would be the tangent value. All right, now let's take a look at 7/6 pi. So we'll do this one in red. 7/6 pi. 7/6 pi is slightly more than 1 pi, right? 6/6 pi would be 1 pi. It would happen to be this one here. So it's this triangle right here. The long side would be negative square root of 3 over 2. It's pointing in the left direction, so it'd be negative square root of 3 over 2. The short side would be 1/2. It is pointing down, so it'd be negative 1/2. So the sine value of 7 pi over 6 would be negative 1/2 because it's the y-coordinate. And then the cosine value of 7 pi over 6 would be negative square root of 3 over 2 because it's the x-coordinate. Finally, the tangent value. The tangent value would be the sine value divided by the cosine value. So it would be negative 1/2 divided by negative square root of 3 over 2. The 2's would cancel. The denominator 2's would cancel. And then we would be left with negative 1 over negative square root of 3, which of course is 1 over the square root of 3. So it would end up being a positive tangent value. Okay? All right, now let's go to the last one, which is 11/6 pi. 11/6 pi is very close to 12/6 pi. 12/6 pi, of course, being 2 pi. 2 pi being 360 degrees, right? So 2 pi would be all the way around one time. But we're going to go just short of that. So we'll be like 30 degrees short of that. We'll be doing this triangle here. So 11/6 pi would be this red triangle. The sides, of course, the short side would be 1/2 long. The longer side would be square root of 3 over 2 long. Square root of 3 over 2 would be positive because it points to the right, and 1/2 points down, so that would be a negative square root of 1, negative 1/2, right? So let's find the sine of 11 pi over 6. That would be the y value here at the y-coordinate, so it'd be negative 1/2. The cosine of 11 pi over 6 would be the x value. The x-coordinate would be square root of 3 over 2. And of course, the tangent of 11 pi over 6 would be negative 1/2 over square root of 3 over 2, which would be negative 1 over the square root of 3. So it would be a negative tangent value. Okay? All right. Let's go to the next one. Number 3, find the exact values of cosine 120, sine 120, and tangent of 120. Okay, so for this one, let's see, we are going to take angles in degrees and map them on the unit circle. So 120 degrees is slightly more than 90 degrees, right? So it would actually be this line right here, the triangle that corresponds to it. We just draw the vertical line down from there. And we're going to look for the sine, cosine, and tangent of this triangle. Remember that the long side is length square root of 3 over 2. The short side is length 1/2. Since it's pointing to the left, it would be negative 1/2. Since it's pointing up, it would be positive square root of 3 over 2. So the cosine value would be negative 1/2. It would be the x value, the x-coordinate. And sine value would be the y-coordinate, so it would be square root of 3 over 2. And of course, the tangent value would be the sine value divided by the cosine value. So that would be square root of 3 over 2 divided by negative 1/2. The 2's cancel, and we end up with negative square root of 3 over 1, but we'll just put negative square root of 3. So that's the tangent value. All right, let's look at the cosine of negative 45 degrees, sine of negative 45 degrees, and tangent of negative 45 degrees. So let's do this one in blue. And basically, negative 45 degrees means that you start at the 0 point and you go backwards. So we would go negative 45 degrees backwards, which would be this hypotenuse right there. This is a 45, 45, 90 triangle, so both sides are the same length. They're medium length, which is square root of 2 over 2. And so we're going positive to the right and negative down. So the cosine value would be the x-coordinate, so that would be square root of 3 over 2, 2 over 2 positive. The sine value would be the y value, which would be negative square root of 2 over 2, and the tangent value is opposite over adjacent, so it would be negative square root of 2 over 2 divided by square root of 2 over 2, which would be negative 1. Okay, and for okay, so some people think that the 90-degree values are some of the hardest. For the 90-degree values, it's hard to draw a triangle. If you would like to draw a triangle at 90 degrees, it would look something like this, like a very tall triangle, but maybe you think it's easier just to draw yourself a straight line at 90 degrees, okay? And then you're like, but how do I look at the sine, cosine, tangent? Well, in this particular case, just think of sine and cosine as the x and y coordinates. So what are the coordinates here for this straight line? It would be 0, 1, right? So the cosine value would be the x coordinate, so it would be 0, right? The 1 would be the y coordinate, so that would be sine of 90 degrees. Okay, so 0 and 1. What can you say about the tangent of 90 degrees? Okay, remember, sine divided by cosine is the tangent value. So the tangent value is 1 divided by 0. 1 divided by 0, that's infinity, right? So that's it, infinity. Okay. Moving on to number 5. Without using the calculator, evaluate sine squared of 60 degrees. Okay, so sine squared of 60 degrees. Let's figure out what sine of 60 degrees is first, and then we'll square it, okay? Sine of 60 degrees, let's draw a picture because they don't want us to use a calculator. So remember, 60 degrees would be this triangle right here, right? And what is the side lengths here? So it would be a one long side and one short side. So the sine value would be the long side, square root of 3 over 2, the y coordinate. So this would be square root of 3 over 2 squared, right? Because the sine of 60 degrees is equal to square root of 3 over 2. So sine squared of 60 degrees. And do you notice they put the squared here? It's the same thing as if they had put sine of 60 degrees in parentheses squared. Okay, so this is like a abbreviated notation for putting parentheses around everything and squaring it. So square root of 3 over 2 squared is equal to square root of 3 squared over 2 squared, which is equal to 3 over 4. Okay, what about C? 4 sine 60 times cosine of 30. Okay, so now I'm going to start drawing these without the unit circle crutch. So sine of 60, remember, looks kind of like this. It would be the long side, square root of 3 over 2. So 4 times square root of 3 over 2. And remember, cosine 30 looks like this. The cosine is the x-coordinate. The long side is the x-coordinate, so it would be square root of 3 over 2 also. So it would be 4 times square root of 3 over 2 times square root of 3 over 2. 4 times square root of 3 times square root of 3 is 4 times 3. 2 times 2 is 4, so it's equal to 3. Okay? All right, let's go to E. Sine squared of 2 pi over 3 minus 1. So basically what we need to do is we need to find first the sine of 2 pi over 3. 2 pi over 3, that is equal to 120 degrees. It would be this tall triangle here, okay, in the second quadrant. So the x and y coordinates would be a short side pointing left, negative 1/2. The long side pointing up, positive square root of 3 over 2. The sine value here would be the y coordinate, so it would be square root of 3 over 2. So the sine of 2 pi over 3 is square root of 3 over 2. If we square that and subtract 1, that would be 3 over 4 minus 1 is equal to negative 1/4. Okay? All right, G. Sine of 3 pi over 4 minus cosine of 5 pi over 4. Okay, so 3 pi over 4, that would be this triangle over here. right, it would be 135 degrees in the second quadrant, okay, because 1/4 pi would be over here, 2/4 pi is pointing straight up, and then 3/4 pi is pointing to the left. Okay, so what are the x and y coordinates here? It would be a medium length legs, so it'd be negative square root of 2 over 2 pointing to the left, positive square root of 2 over 2 pointing up. So the sign value would be positive square root of 2 over 2, right? What about cosine 5 pi over 4? What does 5 pi over 4 look like? 5 pi over 4 is a triangle pointing down into the third quadrant. Of course, it would be a negative to the left and negative down. So both the x and the y coordinates are negative. The cosine value is the x coordinate, so it would be a minus, because that's a minus there, negative square root of 2 over 2, right? So now we have square root of 2 over 2 minus negative square root of 2 over 2. So we need to do square root of 2 over 2 plus square root of 2 over 2. And this is just equal to 2 square root of 2 over 2. And the 2's cancel out, so we just get square root of 2. Okay. Tangent squared pi over 3 minus 2 sine squared pi over 4. Okay, so let's figure out the components here, which is, okay, what is tangent of pi over 3? And then what is sine of pi over 4? And then we'll insert them in the equation. So remember, pi over 3 is 60 degrees. And 60 degrees is this triangle here. And then there's a short side pointing to the right, and there's a long side pointing up. So both of them are positive. The tangent value is the opposite over the adjacent. So square root of 3 over 2 divided by 1/2. The 2's cancel out, so you just end up with square root of 3 over 1 or square root of 3. So tangent of pi over 3 is square root of 3. Okay, so that's tangent of pi over 3. Sine pi over 4. Pi over 4, remember, is the 45-degree triangle. The 45-degree triangle has two sides that are the same length, medium length, square root of 2 over 2. The sine value is the y coordinate, which is positive square root of 2 over 2. Okay, so now let's plug these in, shall we? So tangent squared would be square root of 3 squared, okay, minus 2 times sine squared would be square root of 2 squared. And so square root of 3 squared is just equal to 3 minus 2, and then square root of 2 squared on top. Remember, when you have a squared in parentheses, you're going to square both the top and the bottom. So the top is going to be 2. The bottom is going to be 4. So our answer is 3 minus 4 over 4, which is 3 minus 1, which is 2. Okay? All right. Last one of the page. 2 tangent 150 degrees over 1 minus tangent squared 150 degrees. So let's figure out the main ingredient, which is tangent of 150 degrees. 150 degrees. This is a tricky one, so I'm just going to go up here to the unit circle. 150 degrees, let's see, would be a little bit short of 180 degrees, right? 150 degrees would be here. It's 30 degrees short of 180 degrees. It has a y coordinate of positive 1/2 and an x coordinate of negative square root of 3 over 2 because it's the long side. Now I'm going to redraw it here. So it's going to be negative square root of 3 over 2, and it's going to be positive 1/2. Okay, and so the tangent value of this triangle would be the opposite of the adjacent, so it would be 1/2 divided by negative square root of 3 over 2. The 2's in the denominator would cancel out, so you'd end up with 1 divided by negative square root of 3, okay? And that's it, all right? The negative you could put on the top if you want to. So this is the tangent of 150 degrees. And then I'm going to plug that in to this expression. So I'll put it in the top here. And then I'm also going to put it squared in the bottom. So tangent squared 150 degrees is negative 1 over square root of 3 parentheses squared. Okay, now let's simplify a little bit. We can put the 2 on top here. And then on the bottom, we're going to have 1 minus and negative 1 over square root of 3 squared. The top and the bottom are both going to be squared. The negative sign is going to be squared. The negative sign squared is positive. 1 squared is 1 on top. Square root of 3 squared is 3 on the bottom. So then I end up with negative 2 over square root of 3. And on the bottom, I have 1 minus 1/3, which is 2/3. Okay, and now I know that you guys freak out when you see fractions over fractions. I'm going to do this two ways. One is you can cancel the numerators together and the denominators together, so I could cancel out the 2's and I could cancel out the square root of 3 with the 3. I would end up with, this is the part that's harder to understand, so just ignore this if you don't understand it. So I cancel out the 2's. I cancel out the square root of 3's, except I'm left with square root of 3 here on the bottom. Okay, and then I can invert and multiply the bottom, and I would end up with negative square root of 3. Now I'll do it the easy way to understand, the 5th grade way. Okay, remember that when you divide by a fraction, you multiply by the inverse, so I'm just going to write it out as a multiplication. I invert it and multiply. So now the 2's obviously cancel out, and I just end up with negative 1 instead of these 2's. The 3 and the square root of 3 on the bottom cancel out, and I end up with just square root of 3 on top. So then I end up with negative square root of 3 again. Okay, that's it. Done with this page.